Welcome everyone. Warm greetings from Mercy Technologies. So let's see what is our agenda for today. So our agenda for today is simple 4 points. We'll be digging more into complexity and their growth rates. We'll be having a deeper analysis of log n time complexity. I'll be dealing what is linear search and what is binary search. Right? These are the 4 important things today we are doing, guys. Let me go back. Okay, so yesterday I got replies that a few people were not able to understand what is this time complexity, how it came to log n, how it came to n square, why is it order of n kind of. Let's try to dig more today and I'll try to make you understand all these in better fashion, right? So I'll straight away show you the graph and we'll be deriving this graph as we move forward. So this is a graph, guys. What it says, the order of time complexity is moving just like this line, and in the red color is the order of log n, and order of n square n cube, n power n kind of, right? These are the time complexities. So this is a graph, and this is important for us to understand that when there is order of one time complexity, the time it taken is always constant. Okay, when there is order of log n time complexity, as the data input increases, the log n is also increasing, but not that much. So when it is order of n, it is increasing in a linear fashion. As the input is increasing, the time is increasing. When you take order of n square, n cube, or n power n, it is increasing exponentially. It is too much of increase. So which means with smaller input, you're taking so much of time. That is why we need to avoid our algorithms which are taking this n cube, n square, n power n kind of, right? So for us to understand further on this, let me try to tell you step-by-step process so that we can come until that point. So first thing that I want to do now is I'd like to explain what is an algorithm. Okay. I'd like to explain what is an algorithm. Algorithm in simple words is nothing but a step-by-step process of achieving something. So let's say what I'm trying to explain over here is, let's say a simple algorithm. How do we make a phone call, right? How do we make a phone call? So first thing that we need to do is we need to have a mobile, and there is a proper mobile signal. Yes, if you have a mobile and if you remember the phone number, so what you do, you start typing it, and after that, if you have balance, you can make a call. If not, you come back. So are you in a position to recharge? If yes, then recharge, then make a call. If not, then go back, then terminate. Right? This is a small example. I mean, it has the cases if else, if this, you do this, if not, you come back. So this is nothing but a real case example, a layman example of how do we speak about an algorithm. Similar way, there are algorithms. For example, today we are going to see about binary search and linear search. So in the linear search algorithm, what you're trying to do, in the binary search algorithm, what you're trying to do. So all this we will be digging deep today to understand better, right? Guys, just before I start, so I just want to ask, are you able to see my screen? What are you seeing? Could you please message? So in case anyone has any issues, you please WhatsApp to this number. So in case you feel the screen is stuck and all, if you are connecting from your web, please try to refresh your screen. If it is from mobile, then that shouldn't be giving any problem, but please have an eye on your mobile data as well. Are you able to hear my voice, guys? Is it clear? Please reply. Perfect. Thank you. So in case of any issues, please WhatsApp on this number. Let's move forward in our understanding. So I told you our agenda today is to dig deeper into the time complexities. I showed you a graph. We'll be deriving that graph as we move forward in this session. And we'll be discussing about the binary search and linear search. What are their respective time complexities, right? So here, let's start with what we have left yesterday, right? Going to the whiteboard. Let's start. Okay, so we have stopped our session yesterday by solving this time complexities. These are iterative time complexities is what I said. So here if you observe, guys, here if you observe, the time complexities that we encountered over here is order, yeah, is order of 1, order of n, order of n square, and order of log n, right? So these are the 4 time complexities that we have encountered. Okay, so let me try to explain why this came or what these came. So what I told you is the number of steps that are taken will give us some idea on the time complexity that we need to speak about. So I told you that so in this example we are multiplying by 2 or dividing by 2. In this example our time complexity came to be log n, right? Let me try to explain it to you in a better way so that you will be in a position to grasp that. So in mathematics, whenever you see a log expression, so which means that log expression has to base 10. So what is this? This is in mathematics. But in computer science, whenever there is a log expression, by default, that log expression is of base 2. What is this? This is in computer science. So that can be in different things, but the base can be of different, but in computer science, let's assume for now that it's always going to be the base of 2. So what do I explain you from here is the base of 2 is nothing but, for example, you have some number called n. So how many times you have to divide this number called n by 2 so that you will be finally ending up in 1? Then answer is 1. So this is how you derive log. Let me take a small example for you. Yesterday I told you if you are not clear on the time complexity or the complexities, take examples. Now let's say I'm taking n is equal to 4. So what I can do as my step 1, I'm doing 4 by 2. So now my answer is 2. As my step 2, what I'm doing, 2 by 2. Answer is 1. So as per the definition what I told, we have to divide this number how many times so that we get the answer as 1. So how we are getting? Here we are getting answer as 2. Now let's take one more small example. Let's take a bigger example. Let's say 16. Okay, n is equal to 16. As my step 1, what I'm doing, 16 by 2 is equal to 8. Step 2, what I'm doing, 8 by 2 is equal to 4. Then step 3, 4 by 2 is equal to 2. Step 4, 2 by 2 is equal to 1. So how many steps? The steps are 4. What is the input? Input is 16, right? When the input is 16, the number of steps is 4. So what I want to tell from here is when the input is more and the number of steps that you're taking is less, which means you are having a logarithmic time complexity. Let me explain that to you even in a better fashion. Okay, so what I'm trying to do, I will give you few logarithmic formulae. This is not a maths class, guys. Don't confuse, but these are good to have. Log of 1 is equal to 0 always. Log of a to the base a is 1 always, and log x to the power of p will give you p into log x. So in this case, our base is 2. Our base is 2. Okay, these are three simple formulae. Let's try to make these. Let's try to derive these, right? So what I'm doing, I have told you log of 16 is equal to 4. How do you write it? Log of 2 power 4, and from this what you can write, from using this formula, 4 into log 2 to the base 2. So from this what you understand, 4 into 1 is equal to 4. So using this formula we are concluding log of 16 is equal to 4. Similar way, log of 32 to base 2 is equal to 5, right? So this is how the logarithm is being derived. I'll show you what are the logarithmic values for the first 25 numbers. Okay, one important thing that I want you guys to understand is we are thinking the logarithmic values with respect to the base of 2. When you try to find out the log of base of 10, you will be getting a different value, but here in computer science we are taking the log is base of 2. Here you see the logarithmic value of 1 is 0. The logarithmic value of 1 is 0, and log of 2 is 1, log of 4 is 2, log of 8 is 3, log of 16 is 4, so on and so forth. So all these values are in middle. Let's not dig deeply into all these calculations, guys. What I want you to understand here is when the input is increasing, when the complexity is of log n for 16 is the input, the logarithmic value will come to be 4. Okay, so here let's say the time complexity is order of n. So what does we say? When the input is 16, the number of steps also will be 16. Okay, when the time complexity is order of 1, the input is 16 also, the time complexity will be only 1. When the time complexity is order of log n, which means if the input is 16, the number of steps that are required is 4. Right, the number of steps that are required is decreasing. Now let's say if it is order of n square, when it is order of n square, let's say the input is 4, so which means 4 square 16, right? When the input is 4, it is 16. When the input is 16, which means 16 into 16, which is 256 steps. So when the order of n time complexity for the input 16, we have 16 steps. When it is order of 1, we have only 1 step. When it is order of log n, we have 4 steps. When it is order of n square, we have 256 steps. So this is why the number of steps increase as the complexity increases. So that is why we should make sure that we are coding so that we can avoid this n square time complexities, right? Let me try to derive this graph. I told you that I'll be deriving this graph, right? So I'm just drawing something like this. Okay, so what is this? This is input, this is input, and this is the time taken, or let's say it is the steps. Let's try to plot these values, guys. 0, 1, 2, 3, 4, 1, 2, 3, and 4. So when our time complexity is order of n, so when the input is 1, our number of steps is 1. When the input is 2, our number of steps is 2. When the input is 3, our number of steps is 3. So something like this it grows. right? Something like this it grows. When the input is 4, the number of steps is 4, etc., etc. So what is this? This is order of n. Okay, let's go to our first example. I told you, even though how big the parcel is, if you're taking a flight, it'll take the same time, even if it is a 10 MB file or 1 TB file. So what happens, even though the input increases, our time complexity would be constant, which is only one step. So what is this? This is order of 1. Okay, so now we'll see about the logarithmic value. So what I told you, log of 1 is 0, right? Log of 1 is 0. Log of 2 is 1, right? Log of 4 is 2, right? So something, the graph increases somewhat like this. Okay, the logarithmic graph will somewhat increase like this. This is order of log n, right? Now let's go ahead and see logarithmic value. I mean, the time complexity of n square. For 0, it's 0. For 1, it's 1. For 2, the input is 2. The value is 4, and something like this. The input increases like this, right? So this is order of n square. Now let's say if it is n cube, it increases even more, right? It increases even more like this, right? Which is n cube. So what I want to explain over here is, as the input increases, the number of steps drastically increases in exponential way when our time complexity is of n square, n cube, etc., etc., etc. With a small graph, what we are trying to do, we'll give a rank 1 to constant time complexity. Then what is the next best, which is rank 2, which is of log n. Rank 3 goes to the linear time complexity, and then goes to order of n square, then goes to order of n cube. What I understand is, whenever you try to devise or derive your algorithm, you need to make sure either you have time complexities of order of 1, 2, n, or something like that. So here I'd say quicksort has a time complexity of order of n log n. It'll be somewhere over here. It'll be somewhere, the graph will be somewhere over here like this. Okay, but it is not touching this order of n square, so this is better. But if you take selection sort, insertion sort, etc., etc., the time complexity would become order of n square. So that is why the selection sort, insertion sort, bubble sort, all these will not be of that great use, and people will not be using. People are using quick sort or merge sort because the time complexity is order of n log n. For small number, guys, like if your number is 100, if your number is 10, you do not even need to write an algorithm, because with the fast computational speeds of this generation, this inputs is smaller. But we are dealing with billions and billions of entries, and our time complexity will increase drastically as our input increases. For example, let's say if order of n square, and if our input is 16, we told it is 256 steps, right? But if it is order of n, it's only 16 steps. If it is order log n, it's only 4 steps. If it is order of 1, then it's only a single step. So as the input increases, we should make sure the number of steps get decreased. So that is why we need to use the time complexities order of 1, order of log n, or order of n. We should avoid the time complexities of order of n square. So this is what I wanted to explain to you guys. Just tell me if you're clear about what I have told you till now. Please message me. Understood what I told? There was one person who asked me to explain more about logarithmic time complexity. I think with this explanation, his doubt should be clarified. Okay, cool. So let's go back and see what is our graph that I wanted to show you this morning. And this is what we have derived by taking examples. What we have done, we just took examples. We just took examples and found out and found out that this is how the order of one time complexity does. This is what order of log n does. This is of order of n does, and this is what it is. So what are the types of time complexities? What are the types of complexities that are there? So I would say the time complexities are of below types. Order of one, we call it as constant time complexity. Order of log n, we call it as logarithmic time complexity. Order of n, we call it as linear time complexity. Order of n to the power of a, we call it as polynomial time complexity. N to the power of a means n square, n cube, n power 4 kind of. And we got a n square time complexity yesterday by taking two for loops, right? That is called as a polynomial time complexity. And finally, we came to exponential time complexity. And this is I mean, this is the worst case that we can have, guys. This is the worst case that we can have. 2 power n, 2 power, like let's say a is equal to 10, 10 power, 10 power 10, 10 power 12. I mean, these are two big time complexities. So we'll not be getting this kind of problems in the interviews. These may be faced somewhere in the real time by taking so much of data. There are scientists who do research on this kind of problems. But for us, we'll be concentrating on constant time complexity, logarithmic time complexity, linear time complexity, and polynomial time complexity, right? So this is what we can understand as of now. So with this understanding, let's move forward and try to understand two things here. We, as part of our agenda, we need to see about the linear search and binary search today. So what is linear search? Linear search is nothing but searching for an element at a time without skipping any item. Okay. And what is binary search? You need to cut down your search to half as soon as you find the middle element to sort. Right. Let me go back and explain that to you in a better fashion. So what is our requirement for today? Our requirement is yeah. So requirement for today is we need to find out a number in an array. So let's say this is an array, right? This is an array. This array, the size of that array is 11. Size, what is the size? Size is 11. So in this array, if you see, one more property of this array is it is sorted, right? It is sorted. It is a sorted array. When you have a sorted array, it starts its values are in ascending order. Starts from 4, 7, 10, 14, 21, 22, 36, 62, 77, 81, and 91. Okay. So this is sorted array. When you have a sorted array of this sort, what you have to do, you have to find out something called a number called 22. So how do you find it out? You can find it out. Our first approach is the linear search. So when you have a linear search, as per the definition, we have to consider every element without skipping any element. So what I'll do as part of my first step, I'll start iterating over the array. I'll start iterating over the array. Let me write pseudo code. I'll show you the actual code later. For int I is equal to 0, I less than, let's say I'm directly hard coding it, 11, which is the size of the array, I plus plus. What I have to do, if our input is, let's say, x, right? If x is equal to array of I, return true, else return false. This is a pseudo code, guys. Generally, when this kind of problems come in the interview, generally interviewers ask you to write pseudo code. They really don't want the method names and all and all. But this is how you have to write small code and explain, yeah, this is what we are going to do. We have a single for loop, and after that we are going to return, after that we are going to return the boolean value, either it is true or false. Let's not go deep into it, but here what I try to what I'm trying to explain is, we are having a single for loop. It starts from 0 till n. So first we are taking the index of 0 and trying to see if the input is we need to find 22. Is 22 equal to 4? No. Come to the next. Is 22 equal to 7? No. 8, 10, 14, 21. Then we came to 22. Is 22 equal to 22? Yes, it is equal. So what is we are doing? We are trying to return true over here. So how many steps in the input of 11? We were able to find this in 6 steps, right? Because we need to iterate for 6 times to come to this input called 22. Okay, now this is called, let's say this is called as an average case. Average case, yesterday what I said, which is theta. Let's say it is of 6 steps. But in the best case, your 22 can be directly here, right, instead of having 4. So in that way, the order of one time complexity will come, which is omega, right? But here we need to consider the worst case every time. Worst case in the sense, our 22 can be somewhere over here. Why do we need to consider 22? Because in the worst case, it will take that many steps, which is equal to the size of your array. So what happens here, in the worst case, the number of steps is equal to the input. So in this way, we are trying to find the order of n is the time complexity. I told you previously that if the input is 5 and if the number of steps are 5, which means it is order of n. If the input is n and the number of steps is n, it is of order of n time complexity. As per our graph also, what we have derived over here, let's say we are concentrating on this one. Okay, when order of n time complexity, when input is 1, we have the number of steps as 1. When input is 2, we have the number of steps as 2. When input is 3, we have the number of steps as 3. Input is 4, we have the number of steps as 4, etc, etc, etc. So this is how our time complexity is growing. So with this, what I can conclude, linear search has a time complexity of order of 1. How are we deriving that as order of 1? Because by taking some examples and by seeing that our input is directly proportional, or the number of steps is directly proportional to our input, right? This is what we have done till now. Now let me open up and show you the piece of code, right? This is not very big code, guys. What I've taken, I'm just taking a main method. Let's leave it for now. So there is this method, linear search, right? In this linear search, what I'm trying to do, I'm returning a Boolean value. And here I'm trying to have a method called linear search. My input is array, and what I'm trying to search is int x. This is called as method signature, right? This is called as method signature. Just by looking at the method signature, the interviewer or the person who is trying to review your code should be able to understand what you're trying to write over here. So what you're trying to write over here as linear search, yes, you are returning a Boolean value, you're taking the input as array, and you're searching for an element called x. What I'm trying to do over here, I'm iterating over the input array, and I'm seeing if the input array's value is equal to the input that we are trying to compare, and if it is true, then we are returning true, else we are returning false. So what is my input over here? My input is 10, 20, 30, 40, 50. This is a sorted array. It is having the values in ascending fashion, and I'm trying to search for an element called 166. Let me try to run this program and show you that it should be returning me false. Right, it's returning me false. The reason is we do not have this number called 166 in our input array. Now let me change the input to 50. Let's change our input to 50. Okay, I'm trying to run the program again. Here my output should be true. The reason why it is true is it is already present in this array, right? Since it is already present in this array, we have the output as true. Now I'll speak about the best case and the worst case and an average case. Let's say my input is 10. What I'll do, I'll come into the array and line number 11. At the first time that I come, I see it is already present 10, and finally I'll return, and I will be skipping all these. The reason is I already found my element. So this is the best case. Yesterday I was saying in one of the other case we will be having best cases, right? But we really do not care about the best case, because let's say you're trying to write an application and you're saying it will be performing in order of 1. That will perform only when it is a best case. Now let's say our input is somewhere over here, which is 50. We have to iterate from 10 to 20, 20 to 30, 30 to 40, and then we will come to 50, which means we are taking 1, 2, 3, 4, 5, 5 steps for the input of 5, which means we are having an order of n time complexity. So this is why we consider the worst cases every time. So, and yesterday I told you, using the asymptotic notations, we will be notating that with big O. So in that way, our time complexity will become order of n. I'll try to see. So I'll show you. This is what. Let me explain that to you even in a better way. Okay, so what is our input for now? Our input for now is 10, 20, 30, 40, 50. 10, 20, 30, 40, and 50. So in the first for loop here, we are coming. First we are taking, and our input for now is 50. So first we are seeing if 10 here in this, what we are checking, 10 equal to 50. Is it true or false? It is false, because 10 is not equal to 50, right? Similarly, we'll be doing it for 20, we'll be doing it for 30, we'll be doing it for 40, and then we have something called 50 equal to 50, which is true. So which means how many steps we took? 1, 2, 3, 4, 5. In the worst case, we are taking 5 steps. In the best case, we are taking 1 step. In the average case, it will be somewhere in between 5 and 1. So it can be from 4 to 2. So we really do not care about this average cases case. But yeah, we care about average cases. Not every time we care about the worst case. But here in this linear search, we are saying the order of n as time complexity. The reason is we are considering the worst case, right? This is an explanation of the linear search algorithm. Please reply if you are able to understand this, guys. Then we can skip into, or then we can move into binary search. Are you able to understand? You can reply to this WhatsApp number if you are able to follow my class. Or you can reply to the group as well. So based on your replies, I'll be moving to the binary search. Yeah, time complexity is order of n, because if the input is 5, the number of steps are 5. The input is 10, the number of steps are 10. So it is increasing in a linear fashion, correct? The time complexity of linear search is always order of n. Perfect, correct. Correct understanding, Sharad. Okay, now let's go back to our other topic for today. The last topic for today. What is the last topic for today? Our last topic for today is the binary search. So the binary search, let me come back. Let me input the slide again so that you can understand the binary search also in the same perfect manner. What is our target? A target is to find 22. Okay, our target is to find 22. So as part of that, what we are trying to do, we are now concentrating on the binary search algorithm. The binary search algorithm. Search. So we are concentrating on the binary search. What is a target for now? Our target is to find out where is 22. So this is a sorted array. So what I'm trying to do is my step one would be cut into half, right? You cut this array into half. What is the size of the array? Size is 11. So 11 by 2 is equal to 5. At the index of 5, I'm cutting this. I'm cutting this like this, right? Cutting this like this. So when I cut it into half, what I understand is at the index called 5, there is a number called 21. So what I'm doing, I'm comparing 21 with 22. I'm comparing 21 with 22. So 22 is larger in comparison to 21, right? 22 is larger in comparison to 21. So in that way, what we can do is, as part of our step one, all the numbers which are left towards this 21 are obviously less than 22. So that is why we can discard this whole bunch, right? We can discard this whole bunch because our 22 will never be inside from 4 to 21, right? Because this is a sorted array. So as part of my step one, what I have done, I have cut my whole array into half, right? Now I came to the step two. So with my step two's understanding, what I can see is it can be somewhere in the second half. It can be somewhere in the second half. It can be somewhere in the second half. It can be somewhere from 22 to 91. Okay. So as part of my second step, what I'm trying to do, again, we have an array which is starting from 22 and it is ending at 91. So here also, what is the size? 1, 2, 3, 4, 5, 6. Size is 6 and 6 by 2 is equal to 3. I'll come to the third one, 1, 2, 3. So which is I'm here 62. I'm here 62. So I'm again comparing, is 62 equal to 22? 62 is no way equal to 22. So what I'll do from here with this step, what I understand is there is this part of an array that I can stop considering. The reason is 22 will never be between 62, 77, 81 and 91 because it is obviously less than 62, right? It is obviously less than 62. So again, by our next step, we are cutting it by half, right? We are cutting it by half. Now, so our 22 can be between this 22, 36 and 62. These are the three numbers. So we need to find this 22 between these three numbers. So what I'm trying to do here, again, I will be doing, the number is 3. Again, I'll be doing 3 by 2, which is 1. I'll go to the index of 1, which is 36. Okay, 36. So again, my index is 36. I should consider by now that there is no point of searching in between this. There is no point of searching in between this because 62 is greater than 36 and we do not need to consider because our 22 is less than the 36 as a number. So here again, what I do, I'm left out with only one number, which is 22, which means again I will try to half that number, 1 by 2. So again it will be 0.5. It will be, we can take the max out of it and we can take the ceiling out of it, which will again be 1, and so we'll be coming to this number called 22, and our output will be 22, right? So here, when the input size, again, what I'm trying to do, I'm trying to half it. So in 3 steps, I mean 3 to 4 steps here, I mean, see, the input can be of even, odd, etc., etc. These cases, guys, let's try to find out or dig out more on those cases. But here, what you need to find out is when the input is somewhat near 11, when the input is somewhat near 11, we are taking 3 to 4 steps. That depends on either it is even or odd. We are taking 3 to 4 steps. So when we try to take 3 to 4 steps when the input is 11, which means it is very good or very easy way, or I mean the number of steps that we are taking is very less. So that is why the time complexity also can be less in this case. Time complexity also can be less in this case. So with this algorithm, what we are trying to understand, is we are halving, we are dividing by 2 for every iteration that we are making. We'll go into the code of this one, but from here I want to explain one thing. Just with this analysis or with today's understanding, can you derive without seeing the code, just by understanding this concept, can you say what is the time complexity of binary search? Let's see how the people are understanding. What would be the time complexity of binary search? We are halving for every step. Please reply in the group or in this WhatsApp number. This is a WhatsApp number. Okay. Be attentive in the class, guys. Just try replying. You can be correct, you can be wrong. You can clear your understanding. But without replying or just thinking, okay, I understood it, I mean, that really good. I started receiving the replies. So just by this understanding, what are you able to conclude? The time complexity. Reply, guys. Reply. I think you should be understanding with this explanation. This is our WhatsApp number.
Guys, Surya sir is waiting for your reply. We hardly got only 3-4 replies, but there are many students are there in the class, more than 25 students. Why can't you reply? We are trying to help you. We are trying to know if the answer is correct, we will be sure like you are understanding the concept. In case if answer is wrong, we will think like we will again, Surya sir will make sure you why the answer is wrong. He will try to understand and he will try to help you. But without your reply, we cannot help you. Thank you.
Good that people are replying. So if I get the confirmation, I'll jump into the code and explain you the binary search code, guys. See, without seeing the code, we should get a feeling that we understood the concepts totally. And after you start the pen and paper or after you go to Eclipse, your code should just flow like that. That will happen only when you understand the concept clearly. So here, let me explain this. Let me explain this to you. The time complexity is order of log n, as many people, I think 90%, no, 100% people have replied that to be log n. Appreciate you guys. You understood that in a perfect way. So what I try to explain over here is when the input is somewhere over here, the number of steps that are taken is only 2. When the input is somewhere over 16, the number of steps taken are 4, right? Here, the input is almost 16 for us in the input that we had taken, and the number of steps that are taken is nearly 3 to 4. 4 to be exact. Let's say the input size is 32, the number of steps taken is 5, right? So what we are doing as part of every iteration, we're dividing, or we are ignoring half of the array. We are ignoring half of the array. So after our first iteration, the size of the array become half, and after our second iteration, it becomes again by half, again by half. We are reducing by half. If at the start of our today's session, what is log? Log is nothing but, let's say you take a number, okay, you take a number, let's say 16 in our case. How many times we have to divide 16 by 2 so that that becomes 1? So in this case, 16 by 2, which becomes 8, 8 by 2, which becomes 4, 4 by 2, which becomes 2, and 2 by 2, which becomes 1. So how many steps? 1, 2, 3, and 4. So when the input size is somewhat near 16, the number of steps taken are 4. When the input size is 32, the number of steps taken is equal to 5. So in this way, we are calculating the complexity based on the number of steps. So in our example as well, in the binary search also, what have we done? We have reduced the number of step, the size of the array by half for every iteration. Let me try to open up the code and make you guys understand even more. So what are we taking as per our binary search? As part of our binary search, I have written a method like this: binary search. So what is it returning? It is returning a Boolean value. This binary search method will have some logic. Let's forget about this logic as of now. We'll have some logic. It will try to iterate over this array, and we have an input of some number called x. We have these two variables. I'll tell you what these two variables are, but we have these two variables, and these two variables are responsible to either to reduce the size of the array. So what I'm trying to do over here, there is an input called x. I have a loop. If low is less than high, low is less than high, what I'm trying to do, I'm trying to find out the mid element. Here I did the same. What I tried to do as part of my first step, as part of my first step, I tried to find out the mid. The mid is coming to 21. The mid is coming to 21. So after I find the mid value, I'll compare my value with the mid value and try to figure out if the value that I'm searching either in the first half or in the second half. In our case, 22 is greater than 21, so it should be there in the right half. So which means we have to start searching from 22 to 91. From 22 to 91. So what is our algorithm saying? I'll put the code over here, pull the code over here, and try to explain you how the code is working, right? This is our code that we have written. And what about our input? Our input is something like this. Our input is something like this. So don't confuse with the main method, guys. For example, till you just discard this main method for now. The main method will have an input something like this. What we are trying to search, we are trying to search a number called 22. Our target is to search 22. So first, what we'll do, we'll initialize two values. What is that? Low is this, and high is this. While low is less than high, which means 4 is less than 91. Yes, that is correct. And then what we are trying to do, we are trying to find out the mid, low plus high divided by 2. So the index, we are dividing it by 2, and we'll be having an index of 5. So what we'll have, we'll have a value called 21, which means, okay, we are trying to find out the index value of 5 in the mid, right? And what we are trying to do, we are trying to compare mid with the number called x, and if it is more or less, we are trying to find out in this if else condition. So we are trying to find out, either should we make this one as low, or we need to make this one as high. Okay, so here by just by altering your input, you try to take different inputs and trying to find out what is high coming to, what is low coming to, what is it happening, kind of. So as after our first iteration, we are cutting our array by half, right? And we are discarding this, and now again we are cutting this by half, we are discarding this. So which means for every iteration inside this while loop, for every iteration we are cutting that by half, and finally after in our third step or in the first step, based on the number of based on the size of an array, we will be getting, or we will be finding out the binary searched element. So in this case, let's say the size over here is 11, and in steps of nearly 3, we are able to find out the element to be searched. Let's say it is 16, which means we take just 4 steps. If it is 32, we take just only 5 steps. So in this 5 steps, when the input size is 32, we are able to find out the middle element. Let's say the size is somewhere near 64, 128. Let's say the array size is 128. It's so big array, but you are able to find the middle element. You are able to search that element just in 7 steps. The reason is, guys, 128 can be written as 2 power 7, which means 7 into log 2 to the base 2, which is 7, right? With this understanding, what I wanted to explain you guys is binary search is taking order of n time complexity. The reason is the number of steps that you are having for the input size that you have is very less. So based on that, and based on our logarithmic calculations, we are concluding the time complexity of binary search is order of log n. So every algorithm has its own base case, average case, and worst case. In our case, let's say in this array, so what is that array? So let's say the input is 22 for us, and let's say this is 22, the one that yellow is marking, it is 22 directly. So the first step, in the first hit itself, we are able to find 22. So that is called as best case analysis. The best case, we are able to find our the number that we are trying to search in only order of 1 time complexity. In the worst case, it takes order of log n. So in the average case, it takes somewhere between order of 1 and order of log n. Let me show you the graph for that, so that where your time complexity lies in, you can easily understand. So what is the graph? So it can either be between order of 1 somewhere over here, it can be somewhere over here, or it can be somewhere over here. In the average case, your time complexity will be somewhere over here, lying somewhere over here, right? So it's not increasing. The maximum time it can take is order of log n, and nothing more than that. So this is what binary search for you is, guys, and this is what analysis of time and space complexity, and this is the analysis of logarithmic time and space complexity. So with this, let me ask you if you understood the concept well. Let's see how many people have understood this. Please reply to me on this WhatsApp number. In case of any doubt, we will clear it. We will clear it out just now.
Guys, can you please reply whether you understood or not? If you don't understand, then Surya sir will be helping you. Our intention is all the people should understand 100%. You guys should be master in data structure. So we care about the understanding. Even not even 1% the doubt should be there. We get very less replies. Always replying, updating is very good. That will help us, to understand your mentality, because it's not direct class, right? If it is direct class, by looking your facial expressions, we can, know we can at least predict, but it's online. So always please try to reply. It finally,
Okay. Somebody
it
said
helps you
considering.
only. Sorry.
Somebody said considering array is already sorted. Yeah, binary search can only happen when the array is sorted. Okay. Binary search can only happen when the array is sorted. So that is a prerequisite for binary search.
Might be if you didn't understand fully, it means you might have missed yesterday's class or day before yesterday's class, or you might have joined late. If you didn't get 100%, it means you need to go through the recordings. If you need the recordings, please update us. We will give you the previous class recordings. Because data structure is not that much, straightforward. You can understand at one shot. So continuity is there. Yes, Surya sir, you can continue.
Okay.
Thank you.
Yeah, somebody's asking me, please tell me the method how midterm is comparing with the searching element. See, that is what I tried to explain you over this code. So what you can do is you can try taking this code. So what happens? Let me run this code for you. Let me run this code for you. Let me try to explain you. Okay. So what we are taking the value as 50. Okay, we are taking the value as 50. So we are trying to search if 50 is present, in the array, and we are getting the true as an answer, right? True as an answer. So you want me to explain how this mid and these things are coming, right? So I'll tell you. Let me try to debug this. See, guys, it's very hard to debug everything, but I'll try to explain you how we can find that. Okay. Okay, so here what we are having an array. We are having an array 10, 20, 30, 40, 50, right? This is the array. This is the array. So what is the low here? Low is 0 and high is 4. What is this low? Array starts from 0, guys. The index is 0. So it starts from 0, 1, 2, 3, 4, right? So what is low? Low is 0 and high is 4. And what is that? X is 50, right? Let me move forward. Let me move forward in this. So here what we are
Hold on,
trying to
Surya sir.
understand. Yeah.
Actually, screen got stuck.
Okay.
Yeah, could you please repeat? Now only we are seeing.
Okay, you're able to see. Okay.
Yeah.
Okay, cool. So guys, what I'm trying to explain you over here is, okay, let me stop this and start debugging again. So here my intention is, you're asking how this algorithm is working, right? What is this low, what is this high, and etc. etc. Here we have taken an array which starts from 10 till 50. Guys, you're able to see my screen? Could you please reply?
Yes.
Okay, perfect. So what I'm trying to do, I'm trying to debug the code so that people can easily understand what is low, what is high, and how we are reducing the number of steps. Okay, so let me debug this. Okay, so here I'm debugging what is there inside my array. Inside my array 10, 20, 30, 40, and 50. So this is my array. Index 0 is having 10 and index 4 is having 50. So what is this? The value of x is 50. This is what we are trying to search for. Low is 0, high is 4. Low and high, these both are indexes, guys. These are not the actual array values. Okay, what is low? Low is 0 and high is 4. Yes, I'm trying to find out in this while condition, is low less than high, less than or equal to high? Yes. So I'm trying to find out what is the mid element now. So what is mid? We have mid as 2, the index as 2. Index as 2 means 1, 2, and 0, 1, 2. So now it is present somewhere over here near 30, right? So what we are trying to see is 30 here. AAR of mid is equal to x. What is array of mid? What is there inside this? This is 30, right? 30. Is 30 equal to 50? No, right? 30 is not equal to 50. So we are coming to the next condition. What is that? We are trying to now say low is mid plus 1. What is now low? Low is 3, right? With this low as 3 and high as 4, what we try to achieve here? Low as 3 and high as 4. What is this 3? This is 30. We are discarding that. Here there is 3, 40, and high is 50. So now what happened? All these three things, 10, 20, and 30, these got discarded. As our first step, 10, 20, and 30 got discarded. Now our low is 40 and high is 50. Low is 40 and high is 50. I'm going again inside. Again, I'm trying to find out the mid. What is the mid now? Mid is 3. Mid is 3. What is mid? Mid has become 40 now. So I'm trying to see if it is less, no, and I'm increasing the low value now. So what is the low value? Low value is 4, high value is 4. So what happens? We are again coming to the third case, third step. This is the third time we are coming to this while loop, right? This is the third time we are coming to this while loop. And here, yes, this value should be true now. Yes, we are returning true. And what happens? We are printing true now. We are printing, and that's it. Right? So this is the understanding, guys. This is how you can debug. This is how we see debugging in WhatsApp is one way. While you write the code itself, the debugging should happen inside